All right, students, welcome back to Module 11, Enterprise Systems. Talking a lot about supply chains, and you have interacted with a supply chain. Most often as the consumer buying products, you may have worked in a retail environment where you're selling and sometimes ordering products to sell. And a supply chain is just an integrated network that consists of the organization or your business, the suppliers you have, transportation companies you work with, and different brokers that you use to deliver your goods to the customer. Supply chains exist both in service and manufacturing organizations, and the complexity varies wildly depending on what the organization is, its industry, and its business model. All of this is held together through SCM, supply chain management, and this is the process where we work with suppliers and our other partners throughout the supply chain to improve our procedures and deliver goods and products in a quick, efficient, and low cost way. Quick little diagram here. This is pretty basic, and obviously the complexity of this changes, and there's other steps we're missing out. Most notably, in between each of these steps, there's more distribution steps that we have to work with. So start off, we get our raw materials. This could be things like iron ore, petroleum, natural resources, lumber, trees and lumber. Obviously, that needs to be transported to the supplier. It's not in this diagram, but there's more transportation levels you need to think of and sometimes coordinate. But the supplier takes all those raw materials and they distribute them to your manufacturer. The manufacturer could be something in-house. We might actually develop this in-house. We might outsource it to another company. After whatever this material is, this widget is made, it then needs to go to the realtor. And could be your brick and mortar stop. This could be online, maybe a business to business, business consumer. But somehow, whatever these widgets are that we made, they eventually need to get into the hands of our customers. Obviously, like we said before, this can change wildly depending on what industry you're in and what business model you're in. But there's a lot of factors into this. And your average clerk at a retail store might not fully understand the dynamics of what it took to get their merchandise into that store. It's a very long road. It's a very complicated process. And supply chain management technologies rely heavily on IS, information systems, and the internet. And it wouldn't be an MIS class if we didn't talk about these two things. EDI, or electronic data interchange, this enables your business partners to send and receive information on the transactions that we do on a day-to-day basis. We use the internet and we establish web protocols for the electronic exchange of information. We rely on this to improve our effectiveness of the supply chain, to help lower costs and get goods to our consumer quicker. Internet-enabled SCM provides information sharing throughout the supply chain. We're taking our traditional supply chain, we're adding IoT, Internet of Things devices, other smart devices, which just boost the capabilities throughout the whole chain. It's one thing to know when a shipment left your supplier, but it's another thing to be able to track it on GPS and know exactly where it is, get real-time updates. That way, if if they're late, we can convey that to our brick and mortar stores. We can maybe look for other purchases. We can also look at real-time prices for raw materials. Maybe iron ore dipped down today. Well, let's double our purchase. So anytime we can have smarter and more effective supply chain, we can make better decisions, which in the end lowers our cost and is going to increase our customer satisfaction. Collaborative Planning, Forecasting, and Replenishment, CPFR. And this is used to coordinate supply chain members through POS, or point of sale, data sharing, and joint planning. Basically, any data we collect through our POS system is shared with everybody in the supply chain, and this is useful in coordinating production and planning needs. The goal is to improve operational effectiveness and manage our inventory. If we get real-time data as items are being sold, we can immediately send that to our stock supply. They can immediately order more. The manufacturer could start making more. Goes back to our raw materials. We can start mining, milling, drilling, whatever we need for raw materials. We can immediately bump all of this up based on our real-time data of items that are being sold. A main obstacle to improving supply chain performance is companies not knowing enough about what customers want. This leads to lost sales and unsold inventory. If you've worked in retail, I'll use an example in Richland in Johnstown. Years ago, there used to be a Bilo. It's a Kia dealership now on Scalp Avenue, right next to the Long John Silver's, if you're familiar with the area. Um, Years and years ago, I used to be the frozen food manager. So my main job was ordering and predicting what would be selling. And now, obviously, you get some guidance from corporate. Hey, these are the sales we're going to be running, and the sales are based off of the deals we're getting from our suppliers. But other than that, it was hey, are people going to be buying a lot of Klondike bars next week? I don't know. We really didn't have a lot of real time data or trend analysis, so it was a best guess. It was using your gut, using your experience, knowing your customer base to order. And some of this is just even talking to people. 10 years ago, we would just talk to customers. Hey, what do you guys want to see? What are you buying? What do you want to buy more of? And we do a lot of that now. I'm not working in retail anymore, but that happens a lot. But we could base a lot of our ordering preferences and our ordering habits based on our customers' buying habits. If we know what they're buying, we can then order. If we throw AI into this, then we can predict what they might buy next based on their previous buying habits. If you look at Amazon, anytime you buy something, you're going to see ads for related products. I was rebuilding one of our generators. I got a portable Generac generator. The carburetor needed to be rebuilt, so I bought a rebuild kit off Amazon. Next thing I know, I was getting more ads for carburetors, for spark plugs, for filters, for every other part on it, because Amazon knew, well, hey, he bought a rebuild kit for this generator. He's probably having issues. Well, if you're going to go through the trouble of rebuilding a carburetor for a small engine, you might as well change the oil. You might as well get a new oil filter. Just redo everything while you're there. And Amazon got me. I bought a spark plug. I bought pretty much any consumable for that generator. I bought because I was there. Would I have bought it anyway without those ads? Yeah, probably, maybe. I don't know. But the advertising worked. The system worked. They looked at what I purchased. They threw AI on it. They knew the model of my generator. They knew how to get me. And the supply chain worked. That's the brilliant thing about it. Don't let this slide intimidate you. I know there is a lot going on here, but a lot of this is really just common sense. It all revolves around the consumer because that's everything we do. We want to make sure our customer is satisfied and they get the products and services they need, and just branch out from that. We have supply and demand management, execution, analysis, strategy, and planning. And whether you are an expert in this process or even worked in retail or any customer management position or not, a lot of this just makes sense. If you just follow the circle with the red arrows, this is how things work. We get an order, we generate it, we fulfill it. There's expectations that go through it, performance analysis based on everything. We collaborate. There's a business plan, sales forecasting, and it just goes around and around and again. Um, Focus on this, learn from this, but again, I don't want you to be intimidated on this. I want you to understand the CFR process, but don't let this sway you from it. It's not as complicated as what this slide makes it out to be. 3D printing is something I am incredibly excited for, and probably a lot of that is because I have a 3D printer. But in the manufacturing world, government world, 3D printing is great because it allows us to prototype on the fly. You can draw something up in a CAD program, computer aided design, and then within hours, sometimes minutes, depending on how complicated it is, you can hold that physical object in your hand. Now, is it perfect? No. But it allows us to conceptualize and prototype quicker and faster than ever before because we can make a prototype widget on a 3D printer, and within a day, we can make a new one, do Mark 1, Mark 2, Mark 3, based on improvements that we're doing in-house with hands-on experimentation. Before 3D printing, and this really wasn't that long ago, We would have to draw something up in CAD. We would have to either manufacture it in-house or send it off somewhere to be manufactured. This was a slow process. This was an expensive process. But now, for sometimes dollars, we can print something out and start prototyping with it. And even for, the average consumer, having a 3D printer is great if you're into that sort of cutting edge technology. A story I like to tell, one of my cabinets in our old house, it broke, and it had a very unique hinge on it. I couldn't find a hinge that lined up perfectly on it, and I really didn't want to have to chisel out any of the woodwork to put a new hinge in it. So I just opened up a free version of CAD. I did 2 or 3 iterations, and within a day, I had a 3D printed hinge that worked just as well as the original one, and you really wouldn't know the difference unless you stared at it for a little bit. So, 3D printing is an incredibly powerful tool. We're seeing a lot of this in manufacturing, and it's wonderful. It's a low cost over time. There is an initial investment buying the printer itself, but the filament is extremely affordable. You can make multiple iterations of it. It's a great tool. We're going to definitely see more and more 3D printing in manufacturing, in medical, and in aerospace. Even if you're familiar with 3D printing, you're probably not familiar with 4D printing. So the idea is we have a 3D printed object that can react to stimuli. So the idea is, try to conceptualize with me. Let's say we printed out a large sheet, maybe like a millimeter thick. It was a large sheet, and when temperature cooled down, if it got close to freezing, that sheet would fold itself up into a perfect cube. All right, we're doing these things now. There's a lot of government applications, a lot of medical applications, even aerospace for it. So really, what we're doing, we're printing an object that is, I use the word program, but it's not a computer. It's a physical object that will react in a certain way based on light, temperature, pressure, etc. Some outside force that it'll change its appearance to do whatever we need. So, you can think of this. One 4D printing example I saw was for like medical stents inside your blood vessels. So we can print something up really small and then put it in the blood vessel, maybe heat up that area or cool that area, or even just have it be exposed to liquid, your blood, for so long, and then it would expand, allowing more blood flow. A lot of great uses for this. It's still new. I mean, 3D printing is still new, so 4D printing is even newer. It's really cutting edge technology. But this is going to be amazing to have the ability to have an inanimate object assemble, reshape, deassemble itself based on outside stimulus. I talk a lot about IoT devices, Internet of Things devices, and this is just a huge, broad category of everything. I always jokingly say, "Oh, we have smart light bulbs." Well, we do. We have light bulbs that are connected to the internet. In a supply chain cost, Internet of Things could be, quote unquote, smart boxes that know the items that's inside those boxes. The warehouse knows the location of that box in relation to other boxes. When you think of it in a large supply chain project management mentality, we want to make sure that we are watching our steps. Do we want the guy that loads the boxes to the truck? We don't want him walking out of his way. We want to position things in the most effective manner to get them on the truck as quick as possible. Because you might not think, oh, well, if I save 2 minutes in the warehouse, what does that really do down the road? Well, that can be a lot in the journey of a product from the warehouse to the store. Those 2 minutes you save there could have got him ahead of a traffic accident on the highway that would save him 20 or 30 minutes. So we really need to be as effective as possible, and IoT devices allow us to do this. We can reduce our inventory loss, which, it just allows us to be more effective and more cost conscious as we go through. We'll reduce our fuel cost. In food preparation or food transmit, we make sure that it is delivered and staying at a certain temperature. If the temperature deviates, the driver can get a warning. He can pull over, work on the refrigeration unit. IoT devices are so invaluable, and I think we're learning more and more the importance of these devices, not only in supply chain management, but in just everyday management. Quick response codes or QR codes. Those are the little square UPC barcode looking like things that we see on a lot of marketing advertisements. We're starting to see them on products too. Typically, you'd scan it with your phone. It would take you to the manufacturer's website, or maybe even unlock certain content that, for games or websites or programs that you're using. QR codes are really interesting because they hold a lot of data. Now that's relative because we're talking about comparing that to UPC codes. So the barcodes on the back of your Snickers bar, your cereal box, anything you buy, typically that's a 12-digit number, and each of those bars represents that number. Now there's another standard EAN13, which, surprise, surprise, holds 13 digits. But at the end of the day, that's all the data you have is 12 or 13 numbers. And the way the barcodes work, those numbers tell you a couple things. They tell you the country of origin, the company, and the product it is. And that's it. That's all the information. Where it comes from, what company made it, and what the product is. So you can think of, United States, Apple, iPhone 8. That's kind of the hierarchy of a barcode. A QR code, for example, can hold something like 400 to 500 bytes. That's it, bytes, 500 bytes. But the amount of data and the way we can use that data is so much more adaptable than a regular barcode. It can take you to a website. It can have all kinds of information on there. So you can go to a company's website. Maybe you want to find more information about a TV or something you bought. So you pull up the website on your smart device. You take a picture of the QR code with your camera. It immediately sends the model of the machine, the serial number, service codes, anything else. So there's a lot more information on this. The great thing about QR codes is they're inanimate. It's just printed on a label. So they're incredibly reliable unless that label physically gets damaged. Nothing's going to go away with that data. It is omnidirectional, just like UPC codes. The formatting of the QR and the UPC code tell the machine which way is the correct orientation for it to read. And QR codes can also do characters, letters, even Japanese characters, which is great because we want to think in a global sense for our supply chain, which is a great segue into global supply chain management. Just like local supply chain management, we're using the same mentality, but it's going through manufacturers, warehouses, and retailers worldwide. So using QR codes to mark your products is great because anybody will be able to get that data, much more data than UPC code anywhere, and it can even show Japanese characters for our friends over in Japan. Obviously, we're using a global flow of information, so we want to make sure that our IT is up to snuff and it can handle this influx of information in a timely manner. We can source raw materials cheaper, sometimes quicker. A lot of times this deals with, sourcing jobs overseas. That's a hot topic today. But if that's the best move for the company, we might have to do that. We can increase our markets by going into new untapped markets in areas of the world our company may never would have thought about selling to 10 years ago. However, there's a lot of risk to that. Yeah, your product might sell well in America, but is that going to sell as well or even at all in South Africa or, Southern Asia? It's hard to tell. You can do market research, but that's only really an educated guess. You're also opening yourself up to more competition. Sometimes, just like in this country, people buy made in American items. There are other people that won't buy because they want to buy something that's made in their country, or they just won't buy it because it's from America. So you have a lot of sort of outsourcing issues that may not be relevant when you start going down this road. And there's different legal complexities too. Just because your company complies with the laws in America, you might not comply with laws in any other country. And you might have to really change your operation to even open up a store in that country. Anytime a company goes global, you really need to do your research. Probably have some lawyers on retainer to do initial preliminary aspects. Can we operate in the local geopolitical environment of the country we're going to? And what other aspects do we have? For example, I mean, there's a lot of intellectual property issues when companies operate in the People's Republic of China. Is that something that we can deal with? How do we work around that? A former company I worked to, anytime we had to send somebody to China, they got a special laptop that had no other data on it except for the only information they were going to go to China to talk about. It had no connection to our VPN. It had no connection to our networked devices or servers back in headquarters. This was something we deliberately did to ensure that there would be no or minimal, intellectual property loss. These are concerns that we have to think about when we're working on a global stage. For all the options we talked about for supply chain management, really we have two choices. Do we want to have on-premise options, or do we want to use everything on the cloud? Uh, Really, for the end user, it's the same thing. They're still accessing data, but are we accessing it through remote servers, or are we doing it on site? And there's a lot of advantages and disadvantages for some of this. Obviously, cloud-based enterprise systems have a lower cost. You pay it over time. You're not buying all the servers up front because somebody else bought them already. You're merely leasing these servers. You have flexibility of scaling. You have flexibility of storage. If you need more processing power, great, we can take care of that. If you suspect that you're going to have a large influx of online customers, they can take care of that, and sometimes that's scalable in an instant. They will adjust your bandwidth for your website, or maybe you have different employees coming on. The cloud-based servers can do all of that real time, whereas if you hosted everything in your house, you would have to get more servers, you'd have to up your bandwidth, you'd have to get more processing power, keep buying more and more hard drives and storage devices. It becomes incredibly expensive. But there's challenges with that. When you store your data in-house, it's safe. It's in your building. You put it under lock and key. You have more of a warm and fuzzy that your information is protected. If it's out in the cloud, yes, we're paying a large sum of money for this company to keep our data safe, and they are reputable. But if a malicious hacker wanted to get into something, well, we can get into this cloud-based server and, essentially have our pick of the litter of different companies' intellectual properties, or we can just target this one company. Obviously, that's a simplistic view. There's a lot of roadblocks that a malicious person would have, but these are the things we need to think about. Also, backup too. It's interesting when you back up things on site in your office. Typically, the senior IT manager will have a tape copy, or LTO tapes, obviously, or maybe a solid state drive that every other day he'll back up, and when he leaves, he'll put it in his pocket, and then you have offsite storage. You combine that with maybe a weekly backup that you put in a safe deposit box at a bank. Having offsite storage is incredibly great because if something happens to your building, your data is gone. Some cloud-based services offer offsite backup. A lot of the cloud-based services, they have different facilities sometimes throughout the country, and it's almost like a RAID. So your data would be, maybe in Virginia and Colorado and New York. Some of it is mirrored everywhere, so it'll minimize or prevent data loss if one of those buildings suffered a catastrophic loss. But there's pros and cons for this, and this is not really a conversation that we can get to the end in this chapter or even in this slide. Cloud-based enterprise systems are great. In my MIS 102 class, I always say that the cost of cloud-based storage and processing is essentially zero. because of how cheap and how scalable it is. You're using somebody else's server. You're renting that server. You're renting that space. They do all the maintenance for it. They do all the upgrades for it. You just use it. And that is extremely appealing for a lot of companies to get that overhead off of their site and out somewhere else. But that's a big decision too. And this is where it takes a lot of upper management to understand the pros and cons of cloud computing and how it can affect and benefit your organization. And that's one of the important takeaways I want you to get out of this class. If you get anything from our weeks together in MBA 525, I want you to understand the methodology, the lingo, the words. That way, when the day comes and you're in one of these big meetings, you can talk intelligently and you can be that SME, that subject matter expert on some of these topics to help upper management, that VP, C-suite level individuals make good informed decisions for your company. Keep on working, keep up the good work. As always, if you have any questions, let me know. Thank you.